Descriptive statistics summarize data to show what's happening. They use averages, medians, and measure of variability to describe suppliers' performance, costs, or their key indicators. This is often a very first look into procurement data, giving us a snapshot of current performance, highlighting patterns, and pointing to potential weakness. By applying traditional statistical method at this stage, we can quickly identify basic issues, evaluate the process, and decide where deeper analysis is needed. For example, looking at supplier delivery data can reveal which supplier delivers on time most consistently. Dashboards provide a centralized, real-time view of key procurement data. They integrate traditional or descriptive statistics, such as averages, medians, and variability, to make performance tracking more dynamic. By transforming statistics metrics into live indicators, dashboards enable continuous monitoring of KPIs, supplier performance, and spending trends. Interactive charts are automated alerts highlight delays, overspending, or expiring contracts, allowing procurement teams to measure and improve performance in real time. Correlation analysis is used to measure the level of association between two variables. In procurement, it helps understand whether change in one factor, such as supplier lead time, are related to change in another, like delivery reliability. Typically, we examine one independent variable and its influence on a dependent variable, assuming a linear relationship. The correlation coefficient range from -1 to +1. Values near 0 indicate no relationship. -1 show a perfect negative relationship, as one increase the other decrease, and +1 shows a perfect positive relationship, both increase together. This allows procurement professionals to quantify the strength and direction of relationship between key performance metrics or external factors. Hypothesis testing, also known as A/B testing, is a statistical method used to determine whether and observe results in real or just due to chance. The processes begin by defining a hypothesis, often a null hypothesis stating no difference, and then using a statistical test to evaluate whether the data supports rejecting it. In procurement, it can test whether a new supplier truly outperforms an existing one or whether a cost reduction strategy genuinely lowers expense. A low P, usually lower than 0.05, indicates that the difference is statistically significant and the null hypothesis can be rejected, meaning it is unlikely that the measured difference occurred randomly. This method is valuable in prescriptive analytics, helping determine if an action will have a real impact on processes or systems. Accuracy measures show how close forecasts are to reality. They use metrics like MAE, MAPE, and RMSE to compare predict values with actual outcomes. In procurement, this is important when dealing with uncertainty, for example, predicting demand, delivery times, or prices. These measures help us evaluate how well our forecasting methods perform, identifying which models or tools gives the most reliable results, and guide us in improving future predictors. For example, they can tell you if your demand forecast matches real sales and whether one forecasting approach performs better than another.